gas pipelines. This is not just research. This is the path to red and white gas, replacing LPG imports with self-produced methane gas, saving trillions of rupiah in state funds. Together with Kyoto University, Atomies, and Yachiyo Engineering, BRIN is ready to deliver energy sovereignty for Indonesia.
Research is our strength to overcome any limitations. Innovation is the guiding vision that drives us towards the future. We cannot face this alone. We must stand together to make our vision a reality. Growing strong upon the land of Nusantara, a magical place filled with miracle and wonder. A land spanning 2 continents and 2 oceans, rich in culture and biodiversity. We and Indonesia are the necessary combination to realize the grand visions of the future. Like an orchestra, BRIN harmonizes research, development, assessment, application, and also synergies, invention, and innovation in Indonesia. We created an ecosystem consisting of 7 deputies, 12 research organizations, and 85 research centers dispersed throughout Indonesia. Research Organization for Aeronautics and Space, Research Organization for Nuclear Energy, Research Organization for Energy and Manufacture, Research Organization for Earth Sciences and Maritime, Research Organization for Life Sciences and Environment, Research Organization for Electronics and Informatics, Research Organization for Social Sciences and Humanities, Research Organization for Archaeology, Language, and Literature, Research Organization for Health, Research Organization for Nanotechnology and Material, Research Organization for Agriculture and Food, Research Organization for Governance, Economy, and Community Welfare. BRIN catalyzing research and innovation to develop an advanced scientific ecosystem in Indonesia with 2 main targets. BRIN realizes the tremendous potential of the nation's youth in the field of science and technology. Thus, various research and innovation policies are being formulated to develop and cultivate human resources with high competence and aptitude in science and technology. Creating many excellent programs is a form of BRIN's commitment to researchers, innovators, and the general population from various disciplines across the nation. The research and innovation ecosystem quality improvement in Indonesia is also realized through the collaboration of various ministries, institutions, domestic industries, and regional governments, to name a few, by forming the Regional Research and Innovation Agency, or RIDA. Moreover, cooperation with various foreign research institutions continue to be developed through active participation as member of various organizations and international forums. BRIN organizes research into a more effective and efficient process by integrating human resources, infrastructure, and budget from various research and development institutions. Oriented by a national research priority, BRIN routinely enacts comprehensive evaluations from various research and development institutions. This effort is supported through the continued management and improvement of innovation facilities located across 17 regions of Indonesia, dedicated towards the development of science and technology. BRIN continues to improve our contribution to research and innovation towards national development by developing and revitalizing 4 areas of science and tech, or KST, an integrated area consisting of research laboratory facilities, testing laboratories, and industrial facilities for both startups and SMEs, tenant office rooms, co-working space, meeting rooms, gallery rooms, and other supporting facilities. BRIN is here to manifest the future of a golden Indonesia 2045 by consolidating resources and creating a resource ecosystem and research-based economical foundation, transforming Indonesia as a global reference in the development and application of science and technology practices and the good of humankind. Nature is the source of inspiration. Knowledge is the foundation, and to be put in praxis for the sake of the nation.
Dan luar waktu dulu masuk kurangan. Nah, beberapa saat lagi kami mulai. Terima kasih.
In the world of science, there are discoveries that not only answer questions, but also open doors to the future of humanity. This is the story of Susumu Kitagawa, a Japanese scientist who was awarded the Nobel Prize in Chemistry in 2025. Susumu Kitagawa was born in Japan and showed a strong interest in science, especially chemistry, from a young age. The foundation Kyoto roots. Great discoveries are often rooted in deep foundations. For Susumu Kitagawa, that foundation was built in the cultural heart of Japan. His journey began at Kyoto University, where he dedicated his early years to mastering the fundamentals of chemistry. It was here that he earned his bachelor's, master's, and eventually his PhD in 1979. These years were not just about learning. They were about preparing his mind for a challenge that no one else saw coming. Kitagawa began his academic career as an assistant professor at Kindai University, then became a professor at Tokyo Metropolitan University. In 1998, he returned to Kyoto University and continued his fundamental research on gas adsorption. Far from the public spotlight, he began to question the rigid laws of materials science. While the world relied on hard, inflexible materials such as zeolites, Kitagawa began to explore the unexpected potential of coordination chemistry. At that time, the scientific community was skeptical. Could metal complexes reach a stable manner? In 1998, Professor Kitagawa silenced those doubts. He published a revolutionary discovery showing that porous coordination polymers, PCPs, could absorb gas at room temperature. This was the turning point. He didn't just discover a new material. He discovered that crystals could be flexible, pliable, and dynamic. Susumu Kitagawa is widely known for his revolutionary contributions to the development of metal organic frameworks, or MOFs. MOFs are porous materials composed of metal ions and organic molecules with a three-dimensional network structure and a very large surface area. These materials are capable of absorbing, storing, and separating molecules with remarkable efficiency. The discovery and development of MOFs opens up a wide range of new possibilities, from hydrogen gas storage, carbon dioxide capture, to the development of clean energy and environmentally friendly technologies. The summit, the Nobel Prize. Decades of relentless innovation brought him global acclaim, from the Humboldt Research Award to the Solvay Prize. Yet, the highest peak was yet to be climbed. Finally, in 2025, the world stood in ovation. For his pioneering work in the field of metal-organic frameworks, the Royal Swedish Academy of Sciences awarded him the Nobel Prize in Chemistry, along with Richard Robson and Omar M. Yagi, for their work on the development of metal-organic frameworks. Susumu Kitagawa is now a distinguished professor at KUIAS and ICEMS. He serves as Kyoto University's Executive Vice President for Research Promotion from 2024. Kitagawa envisions a future in which shaft materials lead progress in various sectors of the environment: energy, resources, and health, calling the 21st century the era of gas. His contributions have earned him new in Kyoto to a giant of global science. Architect who taught us that the greatest potential lies in the empty space. This is the story of Kitagawa. Who knows, the next great scientist, it's you.
Porous coordination polymers, PCPs, all metal organic frameworks, MOFs, are a class of porous composed of metal ions or clusters that are regularly connected by multi-density organic ligands, forming a three-dimensional network with well-defined cavities, pores. The main uniqueness of these materials lies in their ability to combine inorganic crystal structures with the design flexibility of organic chemistry, or properties, size, and surface functions to be precisely engineered. Each metal node acts as a coordination center that binds ligands, such as carboxylates or phosphonates, to construct a repeating framework. This periodic array has exceptionally high surface area, often surpassing that of conventional porous materials such as zeolites or activated carbon. The formed pores can range from micropores to mesopores, with their geometry and polarity tailored through the selection of metals and ligands. Functionally, porous coordination polymers excel in selective adsorption of gases, vapors, oils, energy storage, such as hydrogen or methane, heterogeneous catalysis, and drug delivery. The presence of open metal sites and functional groups on the pore walls enables specific interactions, such as coordination bonding, hydrogen bonding, pi-pi stacking, or van der Waals forces, that enhance the selectivity and efficiency of these processes. Another crucial advantage is their tunability. By altering the type of metal, the length of the ligand, synthetic functionalization, the chemical and physical properties of PCP without modifying their fundamental framework. This flexibility makes porous coordination an adaptable material platform for cross-disciplinary applications, ranging from energy capture and health. Porous coordination polymers represent an elegant convergence of molecular design and materials engineering, offering controlled, functional, and customizable porous architectures, a vital foundation for next-generation materials innovation.
Indonesia, a land of immense wealth. We are one of the largest natural gas producers in the Asia-Pacific. Our gas reserves are abundant, stretching from the oceans to the depths of the earth. However, there is an irony. Despite being rich in gas, we spend trillions every year just to import LPG. Subsidies are swelling, and the burden on the state is growing heavier. Why? Because distributing natural gas, whether LNG or CNG, is difficult. Building gas pipelines to every corner of the country requires massive infrastructure costs. Conventional gas cylinders are heavy and highly pressurized. But the future of Indonesia's energy is about to change. The answer lies in molecular-level technology. This is the beginning of a new history. A world-class research collaboration between the National Research and Innovation Agency, BRIN, and the Japanese technology giant, Kyoto University. Partnering with Professor Susuma Kitagawa, the 2025 Nobel laureate in chemistry and the pioneer of porous coordination polymer, PCP, technology. The BRIN research team, led by Dr. Jody Arya Laxmono, works directly with experts at ICEMS Kyoto University to bring this cutting-edge technology to our homeland. The secret lies in this magical material, PCP or metal organic framework, MOF. Imagine a porous nanopowder that acts like a super sponge. With just 1 gram of this powder can be equivalent to a soccer field. It is capable of absorbing and densifying large amounts of methane gas, even at low pressure. This material is then inserted into the cubiton, a revolutionary cube-shaped gas storage container. Unlike heavy round steel cylinders, cubiton is lightweight, easy to stack, equipped with advanced IoT sensors, and much safer. This is the future of gas storage. Currently, proof of concept, POC, trials are intensively underway at the BRIN laboratory. Ensuring this technology is ready for Indonesian conditions. The potential is tremendous. We can harvest methane gas from abundant palm oil waste, POME, in Sumatra and Kalimantan. Then store it in cubiton and ship it to remote islands that are unreachable by gas pipelines. This is not just research. This is the path to red and white gas, replacing LPG imports with self-produced methane gas, saving trillions of rupiah in state funds. Together with Kyoto University, Atomies, and Yachiyo Engineering, BRIN is ready to deliver energy sovereignty for Indonesia.
Sekali lagi kami mohon kesediaan Bapak Ibu yang masih berada di luar untuk
Innovation is the guiding vision that drives us towards the future. We cannot face this alone. We must stand together to make our vision a reality. Growing strong upon the land of Nusantara, a magical place filled with miracle and wonder. A land spanning 2 continents and 2 oceans, rich in culture and biodiversity. We and Indonesia are the necessary combination to realize the grand visions of the future. Like an orchestra, BRIN harmonizes research, development, assessment, application, and also synergies, invention, and innovation in Indonesia. We created an ecosystem consisting of 7 deputies, 12 research organizations, and 85 research centers dispersed throughout Indonesia. Research Organization for Aeronautics and Space, Research Organization for Nuclear Energy, Research Organization for Energy and Manufacture, Research Organization for Earth Sciences and Maritime, Research Organization for Life Sciences and Environment, Research Organization for Electronics and Informatics, Research Organization for Social Sciences and Humanities, Research Organization for Archaeology, Language, and Literature, Research Organization for Health, Research Organization for Nanotechnology and Material, Research Organization for Agriculture and Food, Research Organization for Governance, Economy, and Community Welfare. BRIN catalyzing research and innovation to develop an advanced scientific ecosystem in Indonesia with two main targets. BRIN realizes the tremendous potential of the nation's youth in the field of science and technology. Thus, various research and innovation policies are being formulated to develop and cultivate human resources with high competence and aptitude in science and technology. Creating many excellent programs is a form of BRIN's commitment to researchers, innovators, and the general population from various disciplines across the nation. The research and innovation ecosystem quality improvement in Indonesia is also realized through the collaboration of various ministries, institutions, domestic industries, and regional governments, to name a few, by forming the Regional Research and Innovation Agency, or RIDA. Moreover, cooperation with various foreign research institutions continue to be developed through active participation as member of various organizations and international forums. BRIN organizes research into a more effective and efficient process by integrating human resources, infrastructure, and budget from various research and development institutions. Oriented by a national research priority, BRIN routinely enacts comprehensive evaluations from various research and development institutions. This effort is supported through the continued management and improvement of various research and innovation facilities located across 17 regions of Indonesia, dedicated towards the development of science and technology. BRIN continues to improve our contribution to research and innovation towards national development by developing and revitalizing 4 areas of science and technology, or KST.
Selamat pagi Bapak Ibu hadirin yang kami hormati. Selamat datang Widya Bakti Badan Riset dan Inovasi Nasional pada hari ini Rabu Februari 2026. Ladies and gentlemen, we are going to begin with a discussion, and then we are going to inform you that the discussion conducted in Bahasa Indonesia. Bapak Ibu yang kami hormati, kita akan memulai acara dengan sesi diskusi dipimpin oleh Dr. Mega Mardita. Kita akan tampil profil Dr. Mega Mardita. Beliau adalah praktisi humas di Badan Riset dan Inovasi Nasional. Beliau mendapatkan gelar magister dan juga doktoral di Universitas Indonesia dengan fokus di bidang kebijakan komunikasi. Dan beliau juga akan memperkenalkan seluruh pembicara pada sesi kali ini. Kepada yang kami hormati Dr. Mega Mardita.
Mas Samir. Selamat pagi, Assalamualaikum warahmatullahi wabarakatuh. Saya hormati para tamu undangan, para profesor, rekan-rekan periset. Merupakan suatu kehormatan bagi saya untuk berada di sini bersama Bapak Dani dalam acara kuliah umum bersama kita gawah. Sebelum kita menyimak Nobel Lecture dari Pitagawa, sebagai pengantar kita akan berdiskusi mengenai ekosistem riset dan manajemen talenta di Indonesia. Untuk itu, saya akan didampingi 4 pemimpin luar biasa hari ini yang sudah hadir di ruangan ini. Dan izinkan silakan kepada Bapak Ibu, para pemimpin yang hebat ini. Yang pertama ada Dr. Arthur Lelono. Mari kita sambut pembicara pertama kita, yaitu Dr. Raden Arthur. Baik, Bapak Arthur Aryo adalah Direktur Pendanaan Riset dan Inovasi di BRIN. Beliau berkuliah S1 di Kimia IPB, Magister di Ehime University jurusan Bioresearch and Applied Science, dan doktoral di Ehime jurusan Kimia Jepang. Dr. Arthur bertanggung jawab mengelola skema pendanaan yang bakar aktivitas riset nasional di BRIN. Dan beliau juga memastikan bahwa dapat diterjemahkan menjadi dampak yang nyata. Baik, pembicara selanjutnya, mari kita sambut Profesor Edi Giri Rahman Putra, PhD. Baik, Profesor Edi Giri Rahman Putra adalah Deputi Bidang Sumber Daya Manusia IPTEK atau SDMI di BRIN. Menempuh pendidikan sarjana dan magister di ITB, dan kemudian menempuh pendidikan doktoral di University of Sheffield. Profesor Edi merupakan pakar terkemuka di bidang matter neutron scattering. Beliau juga memegang peran kunci dalam talenta nasional dan program mobilitas periset. Baik, selanjutnya hadirin yang saya juga mendapat kehormatan dengan kehadiran Profesor Dr. M. Fauzan Aziman, Magister of Engineering. Kepada Bapak Profesor Dr. Fauzan Aziman, untuk Profesor Dr. M. Fauzan Aziman adalah Direktur Jenderal Riset di Kementerian Pendidikan Tinggi, Sains dan Teknologi atau Kemenristek. Kemendikti. Beliau menempuh pendidikan S1 di ITB, kemudian magister di Tokyo Institute of Technology, dan menempuh doktoral di Swansea University. Profesor Fauzan memiliki latar belakangnya di bidang teknik dan saat ini memimpin strategi nasional untuk riset dan pengembangan pendidikan. Baik, kita yang keempat dan yang terakhir yaitu tuan rumah kita, Profesor Dr. Ratno Master of Engineering. Kepada Profesor Baik, Profesor Dr. Ratno Nuryadi adalah Kepala Organisasi Teknologi dan Material ORNM BRIN. Beliau menempuh pendidikan sarjana magister di Shizuoka University Jepang. Kemudian Profesor Ratno ini memimpin strategi nanoteknologi dan material di Indonesia, termasuk pengembangan material maju seperti MOF. Baik dan Ibu yang saya hormati, mari berikan tepuk tangan yang meriah untuk seluruh narasumber kita. Terima kasih. Sebelum kita masuk ke sesi tanya jawab tiap narasumber, saya ingin meminta tanggapan para narasumber kita ini, keempat narasumber kita yang terkait tanggapan acara pada hari ini. Yang pertama mungkin ke bagaimana tanggapan Bapak mengenai acara Nobel Lecture ini, Pak? Kami silakan.
Baik, terima kasih Mbak Mega. Saya rasa acara seperti ini sangat-sangat dibutuhkan ya untuk pertama memperluas network kita, sekaligus kita bisa pada Nobel laureate ya, Profesor Susumu Kitagawa. Ya, artinya kami dari Kedeputian Fasilitasi, khususnya Direktorat Pendanaan, mengupayakan support ya, khususnya kegiatan-kegiatan inisiasi kolaboratif yang sister lab, co-funding kolaborasi riset dari teman-teman khususnya di BRIN, kemudian dalam kegiatan riset-riset frontier khususnya seperti ini. Terima kasih, Pak.
Terima kasih. Kemudian pertanyaannya sama nih Pak. Menurut pandangan Bapak, acara Nobel Lecture ini seperti apa Pak?
Baik, saya kira acara Nobel Lecture kali ini merupakan cita-cita, ya, impian kita semua, bagaimana kita bisa menuju ke arah sana, ya kan. Nah, tentunya ini menjadi sebuah inspiring buat kita semua, dan ini merupakan sebuah bagian dari apa yang kita sedang kerjakan sekarang, yaitu manajemen talent di bidang riset dan inovasi. Jadi ini merupakan sebuah kesempatan yang luar biasa yang dimanfaatkan semaksimal mungkin oleh teman-teman semua yang ada di Indonesia, termasuk para talenta-talenta muda, anak-anak muda kita semua. Demikian.
Baik, terima kasih Pak. Profesor Fauzan, pertanyaan yang sama Pak. Menurut Bapak acara Nobel Lecture seperti bagaimana tanggapan Bapak?
Ya, terima kasih. Bagi kami atau bagi kita ada istilah ya, tak kenal maka tak sayang gitu. Jadi kalau kita bisa mengenal, biasanya orang Indonesia juga cukup umum ya, kita kalau ada contohnya bisa lebih mudah bagaimana how to-nya menjadi seorang Nobel laureate ya. Jadi mudah-mudahan tidak hanya dia, tetapi bagaimana beliau mencapai menjadi Nobel laureate, sesuatu yang ingin betul kita pelajari, dan juga mudah-mudahan aplikasi 10-20 tahun ke depan ada Nobel laureate yang hadir, nanti bahasa Indonesia menjelaskan.
Amin. Amin. Baik. Profesor Ratno, ini bukan ini Bapak bukan untuk bagaimana pandangan Bapak terhadap acara ini, karena Bapak tuan rumahnya. Jadi kesan nih Bapak dari Bapak mengenai acara ini, Pak.
Iya, kami sangat bergembira acara terselenggara dengan baik, dan ini merupakan momen yang istimewa karena kita di sini berkumpul para periset, misi, Bapak Ibu dosen, mahasiswa, termasuk juga adik-adik atau anak-anak kita dari siswa SMA ini. Guru juga hadir juga, kita undang ke sini dalam rangka untuk agar kuliah lecture ini bisa memberikan inspirasi, kemudian ya nanti menambah wawasan yang mereka nanti akan masuk ke tinggi. Dan dari sisi Prof. Kitagawa, kita nyebutnya kalau orang Jepang ini ya. Ini saya mendengar bahwa ya sejak 5 Nobel laureates di bulan Oktober 2025 yang lalu, ini pergi ke luar negeri, keluar Jepang maksudnya, dan memberikan kuliah sampai pesertanya sebesar ini itu baru pertama kali. First time bagi
kita kasih tepuk tangan dulu.
Momen yang luar biasa.
Luar biasa.
Saya kira, dan ini juga Bapak dan Ibu ini juga menunjukkan antusiasme dan juga komunitas riset kita di Indonesia terhadap ya capaian-capaian kontribusi ilmiah terutama di bidang beliau, di bidang nanomaterial, material MOF, metal organic framework.
Baik, terima kasih Profesor Ratno. Baik, kita langsung ke sesi diskusi. Sudah ada beberapa pertanyaan untuk para pembicara. Yang pertama saya tujukan kepada Profesor Edi Giri mengenai daya manusia. Ya, Profesor Edi Giri dulu. Baik, kan ada riset itu tidak bisa baik Pak. Nah, Profesor Edi bicara mengenai talenta di dalam Direktorat Sumber Daya Manusia IPTEK, bisa menjabarkan program SDMI apa yang paling menarik dan relevan bagi kita yang hadir di sini, Pak. Secara spesifik, peluang apa saja terkait mobilitas periset, doktoral, atau peningkatan kapasitas yang bisa dimanfaatkan oleh untuk mencetak SDM IPTEK ini.
Terima kasih. Mungkin izin ada sedikit paparan supaya bisa lebih menggambar apa-apa saja yang ada di BRIN dalam rangka untuk penguatan kapasitas riset dan kapasitas periset, tentunya begitu. Dan ini bisa menjadi masukan ataupun informasi yang sangat baik semuanya, baik teman-teman para periset, peneliti, akademisi, dosen maupun mahasiswa dan juga begitu. Nah, tentunya kami di BRIN yang mempunyai tiga fungsi yang utama, bagaimana penguatan ekosistem riset dan inovasi. Nah, tentunya kami tidak bekerja sendirian. Di sini ada kerjasama kami dengan Kemdikbud ini juga makin diperkuat ke depannya dalam rangka tadi penguatan kapasitas riset dan juga kapasitas periset itu sendiri. Lanjut saja mungkin Nah, ini sebagai gambaran di BRIN sendiri, fungsinya adalah sebagai penjelasan kebijakan, kemudian sebagai pelaksana kegiatan riset inovasi itu sendiri, sama dengan dari kampus, dari industri, dari pemerintah daerah, maupun juga dari riset yang ada di internasional, ada di luar. Kemudian juga berfungsi sebagai funding agent. Nanti mungkin Mas Atur akan cerita bagaimana funding terkait dengan pendanaan riset. Saya sendiri akan bicara tentang bagaimana funding dalam rangka penguatan SDM dan juga infrastruktur. Tiga komponen yang paling utama di dalam sebuah ekosistem riset dan inovasi, ada pendanaan risetnya, ada manusianya, dan ada infrastrukturnya. Lanjut saja. Nah, lanjut. Nah, salah satu yang menjadi dasar kita adalah kita punya regulasi dasar hukumnya, yaitu sebuah desain besar manajemen. Dan salah satu bidangnya adalah bidang riset dan inovasi. Tentunya BRIN sekali lagi tidak bisa berdiri sendiri, kita harus bersinergi dengan segala institusi, lembaga, perguruan tinggi dan sebagainya. Makanya Kemdikbud, Kemdikbud, juga Kemenak yang memang memiliki banyak sekali perguruan tinggi dan sekolah, talent pool kita. Bagaimana kita mengelola talenta-talenta muda untuk menjadi talenta unggul ke depannya. Nah, ini tentunya menjadi bagian tugas dari BRIN, bagaimana kita bisa mengakselerasi penguatan kapasitas talenta sejak dari hulu sampai ke hilir. Lanjut. Nah, untuk itu kami di BRIN selama 4 tahun ini sudah memiliki beberapa skema atau program penguatan sejak di hulu mulai pembibitan dan pendampingan talenta. Ini dimulai dari siswa SMA dan tentunya kami harus bekerjasama dengan Puspresnas di sini, Pak. Nggak bisa bekerja sendiri. Tahun ini akan kita kuatkan bagaimana men-scouting, mendapatkan talenta-talenta unggul sejak muda, sejak dini. Kemudian juga ada kompetisi untuk mahasiswa tugas akhir, kemudian juga gang riset. Sebelumnya dikembalikan lagi. Ada magang riset, kemudian juga ada kegiatan yang terkait dengan untuk penguatan teknoprener tentunya gitu. Karena balik lagi tidak hanya kegiatan dengan riset, tapi bagaimana kewirausahaan dan teknoprener di sini. Nah, kemudian di tengah di tengah inilah bagaimana kita kualifikasi dan kapasitas talenta. Ya, satu tugas akhir ya bisa lanjut degree by research untuk S2, S3, kerjasama dengan LPDP untuk memberikan beasiswa doktor ya, dan juga sebagai asisten kami juga memberikan pelatihan dan sertifikasi profesi yang terkait dengan aktivitas riset. Nah, yang paling kanan inilah yang paling penting saat ini, bagaimana kita harus mematangkan setelah selesai S1, S2, S3, what next? Ya, disinilah kami program yang sangat-sangat mendukung penguatan, pematangan talenta unggul. Postdoctoral, ya, visiting researchers, joint research visit, ya, yang paling penting juga kita memberikan sebuah apresiasi kepada mereka yang sudah berkontribusi atas kemajuan, berikan beberapa penghargaan yang di level tertinggi mereka. Ada Habibie Prize, Mutani Award, Salawat Award, dan sebagainya adalah level tertinggi penghargaan kepada insan-insan iptek ada atau nasional tersebut. Jadi disinilah kunci kita bagaimana kita mengangkat talenta kita, talenta unggul kita menjadi talenta-talenta yang bisa berdaya saing selat lanjut. Nah, terakhir terkait dengan acara hari ini, ya ini tadi Pak Profesor membicarakan, mungkin kita tidak sekedar mendengarkan lecture dari Profesor Kitagawa, ya, tapi juga bagaimana what next-nya, ya. Kita harus menciptakan sebuah aktivitas ya bersama, ya. Makanya kami akan menyiapkan sebuah program yang namanya Global Recognition, ya. Dan di sini harus disupport terkait dengan mobilitas risetnya, dukungan infrastruktur dan juga pendanaan, ya. Jadi tidak sekedar hanya mendapatkan pengalaman dari beliau, ya, ya, kemudian juga pengalaman beliau, tapi juga what next-nya. Nah, kebetulan adanya kolaborasi yang sudah berjalan selama ini ya, dengan Profesor kita. Di sini kita harus meng-create sebuah aktivitas, sebuah skema, sebuah program para riset kita, para talenta kita yang terrekognisi secara internasional, dan itu menjadi jalan untuk kita menerima hadiah Nobel. Nah, tentunya harus didukung dengan beberapa kita mobilitas riset. Saya kira ini sangat penting, dan program kami juga sebenarnya sudah dilakukan, tinggal penguatan lebih fokus ya untuk bisa menguatkan ya dengan para periset-periset yang memang sudah mendunia, dan itu kita akan kuat bersama-sama dengan teman-teman dari kampus, dari community saintek, dan semua pihak. Mungkin itu secara gambaran dari kita. Tentunya acara hari ini menjadi penyemangat kita untuk bisa mewujudkan kegiatan tersebut.
Baik, terima kasih Profesor Edi. Sudah jelas ya, kita banyak sekali peluang bisa dilakukan untuk pengembangan talenta yang bisa di-apply oleh teman-teman semua. Nah, kemudian mengenai skema pendanaan ini, itu tidak bisa berkembang tanpa dukungan, benar ya Pak ya? Nah ini kepada Pak Lelono, selaku Direktur Pendanaan, bisakah Bapak berbagi dengan teman-teman semua yang hadir di sini mengenai skema pendanaan yang tersedia saat program mana yang kira-kira paling seksi Pak, atau yang paling menarik buat riset kita, dan tips-tips apa teman-teman di sini atau teman-teman yang nonton secara online juga untuk bisa mengakses. Silakan Pak.
Baik, terima kasih Mbak Mega. Kalau boleh saya dibantu satu yang saya siapkan. Jadi seperti Pak Edi sampaikan, ada 3 komponen ekosistem riset. Pertama yaitu terkait SDM-nya, yang relatif besar bagaimana meningkatkan SDM. Dan yang kedua adanya infrastruktur riset. Lalu yang terakhir enabler yang tidak kalah penting walaupun proporsinya mungkin hanya sekitar, yaitu pendanaan riset ya. Kalau boleh saya ditampilkan oleh panitia saya satu slide saja. Di dalam skema pendanaan riset yang di BRIN di bawah deputi fasilitasi, kami bekerja sama dengan LP itu menggunakan pengembangan dari dana hasil, dana penelitian. Dalam skema yang kita kolaborasikan dengan DP ini, kita memiliki 2 skema besar sebenarnya pendanaan. pendanaan ke arah riset inovasinya sendiri, ya, mengedepankan kebaruan, ya, yaitu riset terkait pengembangan teknologi inovasi dan riset yang ke arah hilirisasi. Skema kami yang kita sebut sebagai RIM, Riset Indonesia Inovasi Indonesia Maju, skema seperti RIM kompetisi yang sifatnya memang bottom up-nya ide-ide kebaruan yang muncul. Lalu itu diusulkan, kebetulan RIM kompetisi ini yang warna biru itu adalah skema yang paling umum, memiliki kurang lebih sekitar 1.006 modul ya yang sudah kita biayai dengan total kurang lebih 1 triliunan. Lalu hampir 60% adalah pengusul penerima di perguruan tinggi dengan konsep kolaborasi. Kita juga mendukung namanya skema hilirisasi, mana ada untuk RIM untuk startup, RIM untuk pengujian produk inovasi. Yang dua ini diusulkan oleh industri. Jadi memang ada yang diusulkan oleh pegiat riset, dosen, peneliti, ya, lalu ada yang diusulkan. Skema yang lain yang termasuk tadi dikaitkan dengan acara ini membangun satu riset inovasi strategis. Hasil kolaborasi dengan Pusat Riset Polimer di bawah Pak Jody dengan kita gawa ini, salah satu mengembangkan MOF tadi, yang mana masuk di dalam itu bagian ketahanan energi ya. Ini saya rasa mampu didorong ya sebagai brio. Nanti kita ingin riset-riset frontiers yang strategis. Itu ada di skema kami yang mana itu berbasis vision driven, berbasis riset yang memang menyelesaikan permasalahan. Dalam konteks pengembangan ke depan yang seperti Pak Giri sampaikan, kita memiliki RIM kolaborasi yang skema ini memungkinkan funding agency. Saya rasa dengan beberapa agensi di luar negeri, JSPS, ya, JST, ya, NEDO, dan kolaborasi co-funding untuk meningkatkan ekosistem riset. Funding agency saling kolaborasi, dan ini kita buka juga untuk perguruan tinggi. Nah, terakhir yang disebutkan sister university, pusat kolaborasi riset internasional, ini bisa kita inisiasi dengan konteks kolaborasi yang sudah kuat berjalan, menindaklanjuti nanti yang ada kolaborasi diskusi terkait pengembangan pusat kolaborasi riset dengan Kyoto University. Kita dari Kedeputian Fasilitasi akan memfasilitasi. Nah, sampaikan mungkin agak kepotong slide-nya ya. Ada 3 fund, ada 3 bisa support terkait di pendanaan risetnya itu sendiri dari berbagai sada terkait mobilitas risetnya. Misalkan teman-teman kalau tadi yang cari sih yang paling bisa menguntungkan kedua belah pihak. Teman-teman dari BRIN perguruan tinggi memanfaatkan skema di SDMI mobilitas di manajemen talenta, mengundang profesor, researcher, postdoktoral untuk meningkatkan ekosistem, ditanam di kelompok-kelompok riset perguruan tinggi maupun di BRIN sebagai contoh. Lalu memanfaatkan ELSA, infrastruktur riset. Ini yang penting ya. Saya rasa ini perlu buka seluas-luasnya. Dalam konteks pendanaan riset, mungkin itu Mbak Mega yang dapat jelaskan sedikit banyak skema-skema yang pasti teman-teman tips triknya harus tahu skema mana yang paling pas. Ya, kalau memang tadi mengedepankan inovasi kebaruan, tim kompetisi. Bahkan untuk hilirisasi atau memiliki kolaborasi internasional ada skema-skema maupun skema yang vision driven yang memang sedang kita buka dan kami berharap kita bisa bekerjasama dengan community scientech. Terima kasih.
Baik, terima kasih Pak Arthur. Ini ada yang menarik banget Pak Al, riset inovasi strategis yang terkait vision driven. Sebenarnya dikategorikan sebagai penelitian yang vision driven itu seperti apa Pak? Silakan Pak.
Baik, terima kasih. Kategori riset vision driven ini basisnya kebutuhan nasional. Permasalahan nasional identifikasi dan menjadi prioritas presiden, pemerintahan. Kita tuangkan dalam bidang ketahanan pangan, ketahanan energi, air, kebencanaan, di berbagai contoh. Lalu yang memang dalam waktu jangka relatif dekat itu memiliki deliverable nyata, luaran riset menyelesaikan permasalahan, apakah itu di pemerintah daerah, apakah itu di ataupun stakeholder lainnya. Jadi vision driven ini sangat kental dengan arah kebijakan sesuai nasional. Lalu ada permasalahan real yang kemudian diselesaikan secara langsung, hasil-hasil riset yang menjadi luaran. Dalam vision driven tidak tertutup juga yang kita sebut untuk frontier research. Ya, frontier yang artinya jangka panjang yang oleh teman-teman di pusat riset polimer, pengembangan kolaborasi dengan kita gawat. Salah satunya memang menghasilkan prototipe beberapa produk. Tadi saya sempat lihat ya untuk strategi, tapi tidak menutup kemungkinan long term research yang memang berpotensi menjadi lahirnya Nobel laureat yang baru. Makasih.
Terima kasih Pak Arthur. Berarti sangat untuk riset jangka panjang ya Pak, karena kan riset bisa nggak cuma setahun, tapi bisa pun gitu. Mungkin ya Pak ya. Baik, terima kasih. Terima kasih Pak Arthur. Kita bergerak ke topik berikutnya mengenai sinergi kementerian dan akses. Ini kepada Dr. Fauzan. Pak Fauzan, sekarang kita ingin melihat gambaran yang lebih luas gitu dari Kementerian Pendidikan Tinggi, Sains dan Teknologi. Dengan struktur kementerian yang baru ini, Pak, apa saja program unggul flagship program dari Kemendikti-Saintek untuk bisa bersinergi dengan yang lebih penting, bagaimana publik serta peserta di sini bisa menjangkau atau mengakses program-program tersebut. Apakah ada platform mekanisme khusus untuk universitas dan lembaga riset untuk berkolaborasi di bawah? Silakan Pak Fauzan.
Terima kasih. Kami siapkan juga sambil menunggu slide. Jadi kemarin ya, minggu lalu, 1,5 minggu yang lalu, kami mengadakan presiden dengan para rektor, ada sekitar 1.200 ya. Waktu itu kita, jadi sebetulnya dana riset kita ini berapa sih gitu kalau digabungkan gitu ya, dari MULPN, LPDP, baik itu DAPL, DAPT gitu ya. DAP sih besar ya, DAP, DAPT, DAPL. Ternyata setelah dijumlah gitu dengan diskusi dengan Pak Arthur, itu total Saintek dan BRIN itu sekitar 8 triliun. Ini dana riset yang bisa tidak masuk gaji misalkan dan lain sebagainya. Nah, Pak Presiden menyampaikan itu yang sudah diberitakan, beliau menyampaikan saya naikkan gitu ya, tambah lagi 50%. Nah ini sebetulnya salah satu cambukan kuat buat kita bahwa BRIN dan Kemdikti itu merupakan satu kesatuan yang ingin kita bangun. Sampai kami sebagai bukti begitu, akhir tahun yang lalu kami mengadakan survei. Kami bertanya kepada 5.942 responden, sebetulnya 1.000 lebih gitu ya. Lalu salah satu pertanyaannya itu mohon kerjasama antara sivitas akademika di perguruan tinggi dengan BRIN melalui Kemdikti-Saintek. Ada 100 usulan ini. Dari usulan-usulan itu, kemudian kalau kita bikin peta kata-katanya begitu, ini cukup jelas, ini yang paling besar itu riset sama memang sivitas akademika di perguruan tinggi ini merindukan, kira-kira gitu. Dan juga kata-kata yang lain itu kalau kita jajar gitu, yang pertama riset, yang paling banyak, ketiga itu kerjasama ya. Jadi memang sudah betul-betul dari sivitas akademi, jadi ini bukan hanya kami di Kemdikti-Saintek di kementerian, tetapi juga di PI yang ingin sekali perlunya kerjasama perguruan tinggi atau DOS untuk kolaborasi penelitian atau riset dengan BRIN. Jadi ini salah satu basis. Slide berikutnya. Nanti silakan, ini laporannya kami dengan senang hati untuk juga ada beberapa masukan gitu ya, tapi 700 jadi cukup banyak. Ke slide berikutnya. Ya, di sini dari 1000 ini ada contoh 3 saja begitu ya. Itu namanya dosen senang nulis mungkin ya. Jadi masukannya itu berbobot gitu bahwa keterlibatan perguruan tinggi di daerah ini belum menyentuh kerjasama riset bersama. Ini yang ingin kami garis bawahi. BRIN dengan BRIDA, kemarin saya dengan Pak Yuk berdiskusi dan bekerja sama, kami membangun beberapa strategi. Memang kalau kita gabungkan antara kampus-kampus, jadi di Indonesia ini ada 1.600 PTN dan PTS. Jumlah sivitas akademika kita ada sekitar 300.000 orang. Jumlah mahasiswa kita kalau di total sekitar orang. Nah ini artinya sebetulnya kita punya pasukan yang cukup tersebar, dan kalau kita gabung berida misalkan di daerah, ini akan memiliki baik untuk mengembangkan dampak kepada masyarakat gitu. Nah di slide-nya, oleh karena itu kami akan jelaskan sedikit latar belakang program di Kemdikti Saintek. Jadi program di Kemdikti cukup sederhana, kami hanya buat 2 rute begitu, kami sampaikan dual track begitu ya, program riset prioritas dan program riset strategis. Kan yang strategisnya namanya mirip, jadi gampang nanti kita mengawinkan begitu. Nah kalau program riset prioritas, inersia yang besar dari perguruan tinggi yang jumlahnya banyak dan juga peneliti yang jumlah, tujuan kami itu kita ingin tetap naik bersama-sama rata-ratanya. Jadi peningkatan pemerataan riset. Jadi kalau kita lihat dari bell curve itu kalau program riset prioritas itu kita menggerakkan gitu rata-rata tengah kita itu dari ke 1 secara horizontal. Nah ini biasanya kami menggunakan dana-dana APBN. Tahun lalu itu program penelitian di Kemdikti Saintek dengan pengabdian masyarakat, jumlah proposal itu 60.000 proposal. Yang dapat kami biayai itu sekitar 20.000. Ya. Nah kemudian sekitar bulan September, Oktober mengenai honorarium peneliti yang sudah cukup lama itu tidak diperbolehkan. Setelah berdiskusi cukup dalam dengan Kementerian Keuangan, Pak Keu dan Pak Mendikti Saintek, kami secara teknis disepakati honorarium peneliti dikembalikan lagi. Langsung ada dampaknya begitu, jumlah proposal yang tahun lalu 60.000.
Kita tepuk tangan dulu dong gitu.
Terima kasih kepada
Yang
tim.
ditunggu-tunggu.
Iya, proposal yang 60.000 tahun lalu, tahun ini jumlah proposalnya jadi 118.000 ini. Nah sekarang harus diputar nih, karena kalau tahun lalu pembiayaan hanya bisa tahun ini pembiayaannya mungkin nggak jauh beda dari 20.000 gitu. Peningkatan satu ya, tentunya dari aspek anggaran itu akan membantu. Betulnya yang menyerap sudah siap. Kedua adalah aspek kerjasama. Jadi bayangkan kami ada 20.000 proposal, ada 100.000 proposal yang mungkin tidak bisa kita biayain. Kalau kita bisa pikir sama-sama nanti dengan BRIN existingnya saja itu kita punya inersia yang cukup tinggi. Nah, prioritas. Kemudian yang kedua itu riset strategis. Kalau riset strategis ini sebetulnya kalau saya kurva XY gitu, kalau X-nya itu strateginya dampak, kita ingin sebetulnya dengan strategi yang baik kita riset-riset di slide berikutnya saya percepat sedikit. Program-programnya itu kami sudah mappingkan juga dengan program-program Pak Arthur ya jadi kita akan sinergikan, tidak akan saya jelaskan satu persatu. Yang menjadi kunci di Kemdikti Saintek adalah kami membangun layer by layer dari ekosistem, riset, hilirisasi, dan puncaknya itu masyarakat. Di mana awalnya riset sekarang saya wajibkan itu jelas problem statementnya apa. Jadi rumusan masalah yang diperlukan masyarakat. Jadi tahun lalu kami investasi berbagai FGD untuk mengumpulkan masalah dari industri, dari masyarakat. Jadi betul mendengarkan apa yang diperlukan dan nanti di ujung piramidanya masyarakat lagi. Dan selanjutnya, cukup detail, jadi nanti slide-nya silahkan untuk dibaca Bapak dan Ibu sekalian, ada di panitia. Kiri itu adalah program riset prioritas kami, 8 industri strategis yang kita coba bangun. Kenapa industri strategis yang kita bawa? Karena Bapak Presiden Sains dan Teknologi itu mendorong pertumbuhan dan pemerataan ekonomi. Jadi kalau udah ujungnya harus ada industrinya gitu. Jadi ada 8, dan 8-nya ada di sini. Oleh STEM dan share ya, ini juga penting sekali ya. Tidak hanya yang sifatnya tapi sosial, humaniora, arts, religious, ekonomi itu menjadi. Kemudian yang di sebelah kanan, nah ini yang program riset strategis. Kemarin juga sekarang di Dewan Penyantun LPDP, bidang-bidang yang diamanahi oleh Bapak Presiden, ini bidang-bidang yang juga oleh Bapak Presiden. Nanti kita bisa gabungkan yang sebelah kanan, kita kalau Bapak dan Ibu masih ingat tadi yang itu kami ingin sebetulnya peneliti-peneliti yang memiliki kemampuan lebih tinggi, jadi yang muda tapi misalkan publikasinya tinggi, itu kita biayai lebih tinggi lagi rate base gitu ya. Kalau yang di sebelah kiri tadi rata-rata semuanya, jadi kita buka semuanya. Jadi kita ada 2 ajang yang kita buka. Anda bisa mulai dari sebelah kiri, nanti kalau sudah memiliki hasil dan merit tinggi, ke sebelah kanan bantu kita menjadi pasukan di depan gitu untuk Indonesia. Slide selanjutnya. Nah ini baru akal-akalan saya. Minggu depan kami akan bertemu, duduk sama-sama lagi. Saya namakan banyak S3 nih, skema sinergi strategis. Karena kita strategi itu Kemdikti Sentek dan BRIN. Kemudian kalau saya lihat minimum sebagai bahasa kita ingin mengintegrasikan pendidikan tinggi, badan riset, dan industri. Dan paling tidak yang saya coba lihat dari berbagai slide yang dikirimkan oleh BRIN dan juga dari kami adalah tadi dengan Pak Arthur dan tim kami membangun tadi bagaimana program riset strategis yang kita integrasikan. Yang kedua, manajemen talent mobilitas dengan Prof. Giri. Kemudian juga akses fasilitas infrastruktur yang terbuka. Kami ingin juga bekerja sama secara ekosistem, baik itu pusat kolaborasi riset, Creation Center, BRIDA, dan STP. Kemudian hilirisasi, baik itu HAKI, Super Tax Deduction, ASI, Startup, Scale Up. Keenam juga jejaring global yang seperti dilakukan hari ini, diplomasi mungkin bisa lakukan bersama. Ketujuh tidak saya sendirikan ini, kadang-kadang lupa bagi kami pengabdian kepada masyarakat. Jadi pengabdian kepada masyarakat sekarang tidak dianakti adalah satu kesatuan yang kunci. Dan semua ini memang harus diawali ini dengan Bu Asti ini, nomor 8, peta rencana induk, rencana aksi, National Innovation Report, GII, yang kemarin juga kami sudah dengan tim GII di Geneva. Untuk tahun ini kita akan memberikan report-report yang jelas ke mereka. Global Innovation Index kita dihitung dengan baik gitu. Jadi kita sudah mulai komunikasi. Kemudian kita mendukung tadi basic applied science. Mudah-mudahan kita mulai bisa masuk ke frontier science technology yang membantu agar riset kita berdampak. Nah, slide terakhir tadi ada pertanyaan apakah kita Bapak dan Ibu sekalian, kami ada di bawah itu linknya, jadi silakan bisa namanya risbang.kemdiktisentek.go.id. Di sini adalah ada 6.000 riset selama 5 tahun terakhir dari 2.100 perguruan tinggi yang bisa dilihat apa saja, di mana saja melakukan risetnya. Kalau diklik nanti kayak Google Map gitu, siapa melakukan apa. Ini penelitian, ada pengabdian, ada hilirisasi, ada produk yang dikembangkan, fasilitas lab, juga permasalahan, tadi kunci sekali. Jadi semua yang 18.000 itu harus ngeklik permasalahan dan pilih satu minimum atau ada di situ kira-kira. Jadi rumusan masalah sudah kita orkestrai. Dan yang terakhir kami buat juga namanya ASRI ini. Kemudian kemarin Pak bukan program ASRI, tapi agak beda sedikit kita. Ini cuma Asisten Riset Indonesia. Jadi kami membuat AI on premise, jadi tidak ke ChatGPT atau tidak keluar. kami memiliki beberapa GPU. Di sana data-data riset secara lokal. Jadi silakan kalau mau dicoba bisa ditanya mirip nanya ke Gemini atau ke ChatGPT. Nanti jawabannya itu agak mirip deep research ya, tapi deep research ala Indonesia. Tetapi rujukannya itu hanya ke riset-riset kita. Jadi Bapak dan Ibu sekalian, apa saja sih yang dilakukan di se-Indonesia oleh para periset kita. Dan juga bisa melihat permasalahan geografi Indonesia, sehingga nanti kalau intervensi juga bisa bantu bersama. Misalkan kalau stunting, kita di populasi cukup tinggi gitu ya, nanti kita bantu intervensi.
Baik.
Kira-kira demikian, terima kasih atas kesempatan diberikan.
Baik, terima kasih Profesor Fauzan. Jadi intinya risetnya itu harus ada nuansa kebutuhan masyarakat, itu yang paling pertama. Baik, ke topik berikutnya, terakhir saya ingin menyapa Profesor Ratno Nuryadi selaku Kepala ORMM. Profesor Ratno, hari ini kita hadir di sini dalam rangka Nobel Lecture mengenai Metal Frameworks atau MOF. Nah, bisakah Profesor Ratno ini menceritakan tentang perkembangan riset MOF di bawah naungan ORMM? Lebih lagi, bagaimana topik riset spesifik ini bisa bersinergi dengan skema pendanaan dan program-program telah disebutkan sebelumnya oleh para pembicara kita sebelumnya. Persilakan Pak Ratno.
Terima kasih Mbak Mega, sambil menunggu slide ya yang akan ditampilkan. Mohon izin saya memberikan
Boleh minta slide-nya, mohon maaf.
Ya ini topik kuliah umum kita Kawasensi hari ini terkait dengan penemuan di bidang MOF, metal, organic framework ya. Nah ini MOF ini kan material kristalin yang tersusun dari ion ataupun juga klaster yang terhubung secara teratur oleh ligan. Nah ini karena strukturnya yang unik itu, dia juga mempunyai stik yang khas ya, yang diantaranya mempunyai luas permukaan yang lebar gitu ya. Kemudian proses sintesisnya juga pendekatan ini bisa dilakukan, termasuk juga ukuran porinya ini. Ukuran porinya ini bisa dikontrol ya, sampai ke level nanometer. Karena karakteristik tersebut, MOF ini potensi untuk dikembangkan dalam berbagai aplikasi. Sebagai contoh, kalau di aplikasi energi, ya oke, mungkin next, ya next aplikasi energi misalkan dia bisa menyimpan gas gitu, seperti gas metana, gas hidrogen gitu ya. Kemudian di bidang lingkungan dia juga bisa menyerap logam berat ya. Kemudian di bidang kesehatan juga bisa dipakai aplikasi sistem penghantaran obat seperti drug. Nah, di kami di Organisasi Riset Nanoteknologi dan Material, mohon maaf, teman-teman periset beberapa ini mengerjakan pemanfaatan MOF sebagai katalis versi next, mohon maaf, next, ya di sini sebagai katalis konversi dari minyak kelapa menjadi bahan bakar pesawat. Kemudian ada juga teman-teman mengerjakan ini sebagai katalis konversi asam lemak ini menjadi hidrokarbon. Dan juga riset terkait dengan aplikasi kesehatan tadi, drug delivery, penghantaran obat, dan juga pengolahan water treatment. Nah, satu yang sekarang sedang menjadi perhatian kami juga, antaranya adalah riset terkait dengan bagaimana penyimpanan gas dalam hal ini dari gas alam gitu untuk aplikasi NG, compressed natural gas, yang ini bisa berfungsi untuk menghentikan LPG gitu. LPG yang ini kita pakai di rumah tangga kita, yang kita ketahui ini juga ini ya, kita masih tergantung pada impor gitu. Nah, ini dengan riset pengembangan MOF di sini ya, aplikasi untuk panan metana, CNG ini harapannya nanti bisa substitusi daripada LPG tadi, karena ini LPG ini termasuk kita tergantung impor, beban APBN juga cukup besar, gitu. Hampir 1 tahun itu kalau tidak salah sekitar 8 rupiah gitu.
Wow.
Jadi kalau kita bisa mengembangkan ini secara mandiri, tentunya nanti melakukan penghematan anggaran negara juga. Dan kaitannya dengan penguatan riset dan inovasi, kami sedang menginisiasi sister lab dengan BRIN dan Kyoto University, dan ini menjadi fondasi penting dalam rangka untuk memperkuat kerjasama khususnya jangka panjang itu di bidang MOF ini. Kemudian next ya, di sesi siang nanti di acara kini, selain nanti ada sesi diskusi young researcher, secara paralel nanti ada diskusi terkait dengan inisiasi untuk membangun MOF Indonesia, yang harapannya ini menjadi wadah bagi komunitas riset kita, periset dari BRIN, perguruan tinggi, industri, termasuk juga mitra internasional, termasuk juga nanti Kyoto University, harapannya begitu ya, yang dengan itu menjadi wadah sinergi, termasuk juga sinergi apply pendanaan.
Baik.
Harapannya ke depan gitu. Jadi kita bisa optimalkan apa yang disampaikan skema-skema pendanaan di misalkan deputi fasilitasi yang disampaikan oleh Pak Arthur tadi, kemudian mobilitas yang ada di Prof. Edi Giri, deputi SDMI, demikian juga skema-skema yang ada di Saintek. Sehingga ke depan harapannya kita periset Indonesia, tentunya mahasiswa gitu ya, bisa berperan aktif dalam riset di bidang MOF di sini bersama dengan para expert kelasnya, sekaligus juga nanti bisa memperkuat kapasitas riset dan inovasinya. Demikian Mbak Mega.
Baik. Terima kasih Prof atas penjelasannya tadi. Jadi kalau rekan-rekan semua ingin tahu lebih dalam hasil penelitiannya Profesor Ratno dan di mana bisa kerjasama mengenai penelitian ini, nah tunggu sampai siang ya Pak ya untuk berdiskusi lebih lanjut. Baik Bapak dan Ibu hadirin sekalian, kita telah mendengarkan wawasan yang sangat luar biasa, mulai dari terkait manajemen talenta dan pendanaan, hingga sinergi kementerian dan masa depan spesifik OF. Untuk itu, saya minta apresiasi lagi dari teman-teman. Mohon tepuk tangan untuk keempat narasumber kita hari ini. Dan saya juga berterima kasih keempat narasumber istimewa kita, ada Profesor Edi Giri, Dr. Arthur Lelono, Profesor Fauzan Azima, Profesor Ratno Nuryadi. Terima kasih atas kehadirannya dan terima kasih insight yang sangat baik untuk perkembangan riset dan inovasi di Indonesia. Baik, itu saya Mega Mardita pamit undur diri sebagai moderator hari ini. Saya kembalikan acara kepada MC Mas Amir. Terima kasih Mas Amir, silakan.
Baik, kita berikan sambutan sekali lagi kepada pada sesi kali ini, sesi pembuka, terutama Bapak Ibu. Silakan merujuk ke untuk berfoto bersama. Terima kasih Bapak Ibu sekalian. Baik, Bapak Ibu kami tepat. Terima kasih. We are going to await for the arrival of the chairman of BRIN, Profesor Susumu Kitagawa. Baik, Bapak Ibu yang kami hormati, kita akan menanti kehadiran uh, Kepala Profesor Susumu Kitagawa untuk memasuki ruangan. Ladies and gentlemen of the National Research and Innovation Agency and Professor Susumu Kitagawa are entering the room. Please rise. Hadir mohon untuk berdiri. Please remain standing. Ladies and gentlemen, the national anthem of the Republic of Indonesia. Ladies and gentlemen, please be seated. Thank you. Honorable Minister of Transmigration of Republic of Indonesia, Honorable Chairman of the National Research and Innovation Agency of Republic of Indonesia, Vice Chairman of the National Research and Innovation Agency, Honorable Charge d'Affaires at Inter of Japan in Indonesia, Honorable Ambassador of Japan to Asia, Honorable Board Directors of the National Research and Innovation Agency, distinguished ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Good morning and welcome Widya Bhakti to witness the Nobel Lecture of Professor Susumu Kitagawa, Day, February 4th, 2026. Ladies and gentlemen, officially open today's event. Please welcome Chairman of National Research and Innovation. Please welcome Professor Arif Satria.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi, salam sejahtera semua. Good morning, ladies and gentlemen. Ohayou gozaimasu. Distinguished guests, 2025 Nobel Laureate in Chemistry, Professor Susumu Kitagawa from Kyoto University, Minister of Transmigration of the Republic of Bapak Muhammad Iftitah Sulaiman Surya Negara, Charge d'Affaires at Interim Embassy of Japan in Indonesia, Mr. Mitsuru, Minister of Higher Education, Science and Technology, Prof. Liarto, is still on the way to this area. Bapak Laksana Trihandoko as the Chairman of BRIN 2021-2025. Bapak Ilham Habibie is our colleagues in BRIN. And rest of the BRIN board and senior leadership, rector, leaders of universities, Director General of Research and Development from Ministry of Higher Education, Science and Technology, and distinguished partner from Kyoto University, Chachiu and Atomic Incorporated, fellow researchers, students, ladies and gentlemen. It is a great honor for the National Research and Innovation Agency of Indonesia to welcome you all to this special occasion. Today's lecture is not merely an academic event, but a meaningful reflection of how fundamental scientific curiosity can generate enduring for society. We are deeply honored by the presence of Professor Gawa, whose pioneering contributions to Method Organic Framework, or MOF, have reshaped modern chemistry. His research has delivered profound benefits to the team, both scientifically and technologically. MOF have enabled through gas storage and separation, water purification and treatment, drug delivery systems, and energy-related applications. These materials have demonstrated strong commercial potential, supporting the development of scalable for industry, environment, and healthcare. His work exemplifies how fundamentals open new pathways toward addressing global challenges in energy, environment, and safety. For Indonesia, these advances are particularly relevant as our presidents take one of the priority for development is how to achieve energy security. And today also get gas from Dewan Energi Nasional, Pak Sat, the director, the board of National Energy. Also Pak Sekjen, Deputy Saintek. And one promising direction of MOF-based technology for compressed natural gas storage or compressed natural gas. Indonesia is endowed by abundant natural gas resources which can be utilized domestically without reliance on import. At present, our energy system still depends significantly on imported LPG, petroleum gas, and here MOF-enabled CNG storage technology offers a strategic opportunity to support national energy resilience, reduce import dependency, promote cleaner and more sustainable energy utilization. Yesterday, I met the President of Republik Indonesia, yesterday meeting in Istana Negara, and the presidents about this event that we have the special guest from Japan, Prof. Susumu Kitagawa, to give lecture in BRIN. I also talked to the presidents that between Professor Susumu Kitagawa have the collaboration in MOF. Very, very happy hearing it and support this, how to support the president's priority in achieving national energy security. This event also highlights the strong and growing collaboration between Indonesia and Japan. BRIN plays a central role in ensuring that such collaborations translate into concrete capacity buildings. We are strengthening human resources, research infrastructure through the optimization of researcher mobility schemes, enabling our scientists, including students from universities, to in international research ecosystem. In parallel, the initiation of laboratory program between BRIN and Kyoto University allow joint utilization of research facilities, fostering hands-on collaboration and long-term knowledge transfer. Through Indonesia researchers and students are actively engaging with world-class expertise, strengthening our national research capacity and global outlook. In parallel, BRIN continues to advance strategic collaborations that connect fundamentals with real-world applications. Today, important milestone with the signing of Memorandum of Understanding between BRIN and the Mineral Energy Industry Agency, innovation in the strategic mineral sectors. This collaboration reflects our commitment to translating science into tangible contributions for national development. Furthermore, we are witnessing how international co-development efforts among BRIN, Kyoto University, engineering, and atomics are pushing forward technological innovation storage systems. This collaboration demonstrates that research on MOF is not only profound, but also highly relevant to industrial and environmental solutions. Your presence here serves an inspiration. This Nobel lecture is a cut for our young scientists and a significant step towards strengthening the research community in Indonesia. We hope today's event will spark deepen international partnerships and accelerate innovation across an industry. Finally, by saying Bismillahirrahmanirrahim, I officially open the Kitagawa Nobel Lecture 2026. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you very much for Professor Satria. Please return to your seat. Ladies and remark will be delivered by Charles Dafer, at interim of the Embassy of Japan. Please welcome Mr. Miyochin Mitsuru.
Distinguished Professor Kyoto University, His Excellency Professor Alex, Chairman of BRIN, His Excellency Professor Amalula Octavian, Vice Chairman of BRIN, His Excellency Mr. Iptita Sulaiman Sriyanagara, Transmigration, His Excellency Dr. Laksanatri Handoko, former Chairman of BRIN, Dr. Habibi, Chairman of the Habibi Center, distinguished guests, ladies and gentlemen, good morning. Salam pagi. It is a great honor to address you on behalf of the people and the government of Japan. This occasion, Nobel Prize lecture by Professor Susumu Kitagawa at BRIN. Professor Kitagawa's Nobel Prize research is not only of outstanding value as fundamental science, it also holds great to contribute to addressing the critical challenges that Indonesia faces in fields of energy and the environment. In particular, the application of metal organic frameworks, or MOFs, household energy is expected to bring significant benefits. This is heat sources that are closely connected to daily life. Such applications are expected to make people's lives safer, more comfortable, and more prosperous. Furthermore, MOF technologies can promote of Indonesia's domestically produced energy resources, such as by this will contribute to energy security. It will also help to address disparities in energy access across regions. I firmly believe that these efforts represent an important step toward more prosperous and resilient Indonesian society. implementation of these research outcomes has been supported not only by the ambitious initiatives of startup companies. It has also been supported by the accumulation of international cooperation built, maintained, and advanced over. These efforts are the result of the dedicated work of our predecessors. Japan and Indonesia have steadily deepened the cooperation of science and technology. This cooperation has provided a vital for collaboration among industry, government, and academia in both countries. In addition, a wide range of scholarship programs and people changes has been implemented. These efforts aim to nurture the mission of researchers and engineers. At the Japan Summit meeting held in October last year, the importance of human resource exchange was once again, it was recognized as a key pillar supporting long-term ASEAN countries. At the embassy, we will support these efforts with a full commitment. Looking ahead, Kyoto University and BRIN will continue to join research aimed at the further utilization of MOFs. In addition, a way to establish a joint research laboratory between the two institutes. These initiatives are expected to enable research collaboration and human resource development in a more systematic and sustainable manner. They will strengthen academic cooperation between Japan and Indonesia. The Embassy of Japan will continue to actively support these efforts in science cooperation and human exchange. We will do so to ensure steady development. In closing, I am truly looking forward to today's deep respect and anticipation. I wish Professor Kitagawa continued success in his future endeavors. Thank you. Terima kasih banyak.
Ladies and gentlemen, we are welcoming His Excellency Ministry Nations, Science and Technology. Ladies and gentlemen, for the next remark, please welcome Minister of Higher Education, Science and Technology, Professor Brian Yuliarto.
Terima kasih. Assalamualaikum warahmatullahi wabarakatuh. Shalom Om Stu, salam sejahtera bagi kita semua. Your Excellency Mr. Yokoji, Ambassador of Japan to ASEAN. Your Excellency Mitsuru, the Affairs at Interim Embassy of Japan. And of course our laureate Professor Susumu Kitagawa. Thank you for coming here, Mr. Professor Susumu Kitagawa Sensei. Yang kami hormati Mr. Minister Pak Iftitah Sulaiman, terima kasih Bapak. Kami hormati rekan kami, Kepala Profesor Arif Satria, kemudian Wakil Kepala BRIN, Profesor Amarullah, Bapak Profesor Dinegoro, mohon maaf. Kemudian Pak El, Kepala BRIN sebelumnya, kemudian dari PMK Bapenas, Bapak Pungkas Bajuri, Bapak Jen Kemdiktisaintek, Pak Prof. Togar, Bapak Dr. Ilham Habibi, Ketua PI, Bapak tamu undangan lainnya, dan Bapak Ibu semua yang hadir. Of course, I send gratitude to Almighty God for His grace. We are able to gather today of great significance for strengthening the quality of Indonesia research, technology, innovation, science, and ecosystem. As we know that Minister of High Science and Technology and BRIN, National Research and Innovation Agency, pivotal institution in Indonesia's effort to develop globally competitive human capital and national competitiveness toward Indonesia Mas 2045. Distinguished guests, collaboration between the Ministry of Higher Education, Technology, and BRIN has taken place for many years, both through programs at the central as well as within universities and work units, amid changes in the nomenclature and organizational structure. The signing of Memorandum of Understanding between Ministry of Education, Science and Technology and BRIN today serves momentum to reflect on the collaboration that has been established thus far and our joint efforts in a more strategic and system manner for the future. Actually, of course, without signing MOU, we already work very close between and many universities. We thank you also to provide many support for our professors, our lecturers, students as well. We really hope today's event also will make our join together will be more, and I believe also that we are very welcome for next programs. I think our Director General and the Deputy already work together in more detail to make sure that all programs will be in good coordinations. In our discussion with DPR, we also request them to work together. I said that we already work together, and today we will sign MOU, and I believe that today's event will strengthen and many challenges in front of us to make our country being advanced country, following examples who can run very fast in age of 90s, I think, and by support by Japan's government, I believe we can even faster. And I think today's lecture is very great lecture. I know very well Professor Gawa. Actually, is one of our prominent sensei because papers as well his lectures in several international prominent events, academic. It is our great opportunity for us. Also, we invite others Nobel laureates, professors Sumo Sensei. We invite 2022 in Universitas Hasanuddin. He is also chemical from Copenhagen University. The theme is about click chemistry. So I think this is very great examples. Let's follow the lectures. Let's learn how the professor can do research in the world-class impact. And I think one point that we have to learn is how we can be a patient professor, patient researchers, because we believe many or prominent research professor, world-class professor, they do research continuously, they do research simultaneously by other things, and they do involving many colleges. The collaboration is the key, I think. So let's make great collaboration between BRIN and the universities in Indonesia. So it's my sincere appreciation to the working teams of both institutions, BRIN and from Dikti Saintek, who have formulated the implementation mechanism for this collaboration. Let us prove that this partnership is not merely ceremonial, but a beginning of a true resurgence of science, technology, innovation, and higher education in Indonesia. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam. Waalaikumsalam warahmatullahi wabarakatuh. We would kindly ask for Profesor Brian Yuliarto to come to the stage. Kami persilakan kepada Profesor Brian Yuliarto untuk menuju ke depan panggung to witness together the signing of Memorandum of Understanding between BRIN, Mineral Industry Agency, and Ministry of Higher Education, Science and Technology. And for that, we would Professor Arif Satria to come to the signing table. Sepanjang yang pertama adalah antara Badan Riset dan Inovasi Nasional dan Badan Industri Mineral tentang riset di dalam rangka pengembangan industri mineral strategis. Nota kesepahaman yang kedua adalah Kementerian Pendidikan Tinggi Sains dan Teknologi dan Badan Riset dan Inovasi Nasional tentang sinergi penggunaan tugas dan fungsi bidang pendidikan tinggi, ilmu pengetahuan dan teknologi dengan bidang riset dan inovasi. Thank you very much. Please return to your seat. Gentlemen, next we are about to witness the signing of agreement between Research Center for Technology of BRIN, Geoengineering and Atomies on research development and phase 3 Cubiton operational environmental demonstration. And for that, we would like to invite Dr. Jody Arya Laksmono, Mr. Haji Mebe, and Mr. Daisuke Asari to come to the signing table. First signing will be done by Dr. Next, signed by Mr. Hajime Watanabe. And the last from Mr. Daisuke Asari. Thank you very much. Please return to your seats. Ladies and gentlemen, now we are going to have a photo session. And I'd like to invite Professor Brian Yuliarto to come to the front of the stage. And also Professor Arif Satria, Dr. Muhammad Iftita Sulaiman Surya, Mr. Miyochin Mitsuru, Mr. Ione Tanikoji, and Professor Amrullah Oktav. Okay, the count on me. 1, 2, 3. Once again, 1, 2, 3. And we are going to invite also the board of directors of BRIN. Ya, ini mengundang juga kepada para pejabat eselon 1 BRIN untuk berfoto bersama. And to your seat, silakan kembali ke tempat and please rise, silakan berdiri Bapak Ibu sekalian untuk sama dengan seluruh peserta acara pada hari ini. Ladies and gentlemen, please, as we are going to have your pictures taken together from the stage, please. Yang di tribun silakan untuk bisa berdiri, adik-adik sekalian. Adik-adik silakan untuk bisa berdiri karena kita akan mengambil foto. Oke, let me count. 1, 2, 3. Sekali 2, 3. Perlu gaya bebas palkan tangan mungkin, Mbak? Silakan. Oke. Alright. 1, 2, 3. Once again, ladies and gentlemen. 1, 2, 3. Please give round of applause. Ladies and gentlemen, take your seat once again. Terima kasih adik-adik sekalian, silakan duduk kembali.
Ya, kalau ini kan sama jadi sirkulat nanti. Maju kosong.
Ladies and gentlemen, before we are going to listen for the Nobel lecture in chemistry, we are about to see the video profile of Temu Kitagawa.
World of science, there are discoveries that not only
Ladies and gentlemen, now of today's event, it is our honor for us to listen to the lecture from the 2025 Nobel laureate and together with Professor Agus Haryono, Deputy for Facilitation of Research and Innovation of BRIN, earned his doctorate degree in applied chemistry from Waseda University, and to Professor Agus Haryono.
Good morning, ladies, distinguished guest colleagues, and occasion the Nobel Lecture Series by National Research Innovation Agency in collaboration with Kyoto University. My name is Agus Haryono, Deputy Chairman for Research Innovation and Facilitate BRIN, and I am very honored to serve as your moderator this prestigious sessions. We are gathered here today to witness on scientific exchange between Indonesia and Japan. The privilege to host has not only defined their science but also profoundly impact understanding of the world. Ladies and gentlemen, today is a titan field of chemistry. Professor Susumu Kitagawa was the Nobel Prize in Chemistry just in October 2025 for his pioneering work on metal organic framework. This has opened avenue in sustainable energy methods, bridging the gap between fundamental science and applications. Currently, Dr. Professor Kitagawa also serves as a distinguished professor at Kyoto University Institute of Advanced Studies and is Vice President and Research Promotions. The first Nobel lecture in Indonesia. Thank you very much, Professor Susumu Kitagawa. The usefulness of useless fundamental and the impact. So we are eager to hear his insight. So without further ado, in giving warm round of applause to our distinguished speaker, Professor Susumu Kitagawa. Ohayou gozaimasu. Very much for computer science. Your time is 45 minutes and continuing by Q&A session.
Very much kind introduction. So good morning, the Excellencies. Professor Arifu Satori, Chairman Brian Marialto, Minister of Higher Education, Science and Technology, Iftitas Raiman Sri Nagara, Ministry of Education, Rahmat Pambudi, Minister of Bapenas, Raghunath Tori Handoko, former Chairman of BRIN, Ilham Abibi, Chairman of Indian Engineering Association, and Mr. Miyochin Mitsuru. So many, I'm very happy to be here. And also I'm so wonderful to see young people who are interested in the science and technology for our future. So let me talk with this slide. And okay. So today my title is the Usefulness, Fundamental Curiosity, Enduring Impact. So maybe you don't understand why this title will come in this scientific talk. Let me start. My talk contains 3 parts. First, let's look at the current world, and second, my chemistry, and third, future. So in the 19th century, man created a new technology that produce that lot of energies. That time, people use coal energy resources. In 20th century, people use the petroleum, as you know. So what about 21st century? We think we use gas substances. So the technology is expanding and developing from the solid and liquid gas substances. These are small gas substances, or the small molecules, contain 2 or 3 atoms. So they are widely distributed in the world, and they are associated with the environment. Automatic change. What's happening? Okay, but look at this. They are related to the environment, natural resources, energy. Even, however, humankind is still not in control of gases. Okay, so now currently we are standing at this state. We use the underground resources. However, the deep underground resource and also warming is a big concern because our society is dependent on non-resources. So we have to switch to the other society that is underground resources dependent on ubiquitous resources. That means the air or gas, okay? However, the substances are easily diffuse and we can not see the gas substances. And they are short life, some gas substances have a short life and also the toxic. So in order to handle these substances, develop the new technologies depending on, and in particular in the focusing on this and the storage and the conversion. So we look at the history of materials. And the 3,500 years ago, the Egyptian era people used the porous materials that activated, it's a charcoal. And 80 porous materials were found in the natural rock. So we call zeolites. But this is a kind of the underground resources. But the people, the artificial synthesis in the 19th century and 20th century. So that reason why the zeolites contribute to the very much for the petrochemical. So what is interesting in the 19th century, Nobel invented the dynamite. The dynamite contains nitroglycerin. This is very explosive materials, but he used the porous material. That is the Kizegua. Okay, so history of Nobel Prize just start at the porous materials. What's interesting. Anyway, I told you in the previous slides, and we need to develop more and more the excellent porous materials. That is the point. Today I'm going to talk about metal complexes. So in the Richard Robson and Mayagi were awarded Nobel Prize in last year. This is diploma and the medal. Okay, so the focused on the porous materials we call mark. So the in the synthesis is very simple. Choosing metal ions, organic ligands. It's okay. So, from the metal ions and the organic molecule, we can get this kind of network frameworks and very diverse. This is metal organic frameworks. So I told you in the previous slides, by using metal, it does not. Why? Okay. Little bit delayed. Sorry. I have to speak more slowly. And you see here. So for instance, in the air contains this type of elements: carbon, oxygen, hydrogen, nitrogen, and other elements. That means, for instance, even for these 4 elements, you can see your body in particular are constructed from these elements. So that means from the air, we can a lot of materials for to do this, the separation and storage and processes. If we develop more and more these processes, we can live in the air, okay? And with air. So in a sense, we can say air is invisible gold. This is the value. To do this, we have to develop more and more chemistry, science, and technologies. So let's go on to the part 2. I did this kind of chemistry. So, and Louis Pasteur said, prepared mind, not by chance, but how a questioning the door to science. My case, prepared mind, 3 notions. Is number 1, assembly. Structure arises from elements. Space, function emerges from nanospace. Dynamicity, okay? Everything flows, nothing stays. I'll tell you what. First one, assembly. When I was the undergraduate student, I learned there are many the branches of physics. I learned. Ultimately, I faced statistical physics. It was very, very impressive. In particular, in the Boltzmann equation, connect nanospace, scale materials, and macro scale materials. Okay. The second is the biomolecule. There are many molecules in our body. For instance, more than 100,000 human proteins. They are synthesized from only 20 amino acids. Only 20. Just assembly of this kind of amino acids. So we can get many functions. So fantastic. So assembly is a very big, important keywords. The second. Also, the student, graduate, undergraduate students, and I met the Hideki, the very fantastic book. That is The World of Genius. He was the first Nobel laureate in Japan and physics. And in this book, he introduced the very old philosopher in Asia, Chan Tzu. He said, the usefulness were useful. So that means everyone knows the usefulness were useful. No one knows the usefulness were useless. Do you understand? So Hideki Yuka said, this is a thinking, this is a thought of creation. Very important. For instance, there is nothing or useless, but this is a sort of the space. The molecules and ions, the space can be freely manipulated. That's useful. Okay? So nothing but in the useless side, that's this kind of the small space, integrated these spaces to the infinite, like that. Materials, you see. So the third, dynamicity. This is very important. When I was high school, I learned the philosophy, in particular, and so Heraclitus said he was also the 200 years ago. He lived in the Greek. So Pantaleon. That means everything flows. And so I was born in the Kyoto. Kyoto is the old capital. 1,200 years, so many cultures and novels, books, essays. So I read this kind of things. My background, just like in change. And also Buddhism. Buddhism, all forms arise and pass away. So permanent things, we cannot believe permanent thing. Everything change. This is our mindset. So please keep in mind and three notions and enter the Kyoto University and in the Kyoto University, I entered the Professor Fukui's lab. Okay. So in the Professor Fukui's laboratory, there is a top disciple in the Professor Yone belong to this. But this laboratory is just a quantum physics. So in this university, after graduation, I belong to the Kindaki and then the Tokyo Metropolitan University and back to the Kyoto. In each university, I developed this notion, assembly, dynamicity. So look at the, for instance, this kind of the framework, porous framework structure, make it. How we can make it? Well, this is the famous the temple in Kyoto. So this temple has a big balcony where you can see the Kyoto city. And if you look at this balcony, this is constructed from the 100 the Zelkova trees. Okay, no peg was used. This is very construction like this. In the macro scale, we can do this. How we can make this kind of porous structure? So this is still the toy. That imagination, how to make this kind of framework. But in this case, do we have a magnet in the nanoscale? This is a question. Yes, we have. We call coordination bond. This bond connects the molecules and the metal ions. By using this bond, we can construct of the framework automatically. Okay, like this. So you have organic molecule and metal ion, two solutions we mix. This movie is very heavy. So if in this my screen, it works very, very beautiful. Oh, so reaction does not like this. Very continuous. But anyway, we can make this kind of beautiful structure. Okay. Okay. Please think about that. You have 1 millimeter. Okay. So in this morph materials, we can do a structure like this. Oh. Very slow motion. Okay. So each the size is 1 nanometer. So that means one side, 1 million. The vertical side is 1 million we have. So 1 million times 1 million means billion channels per 1 millimeter crystal. So 1 millimeter is too large. 1 micron is enough. Okay. So this is materials. So here in these materials and the gas molecules, the adsorbed, we still freeze. Okay. and weight go into the channels, and side the gas substances accommodated in that way. Yeah, today 2 hours. Sorry, my talk takes 2 hours. So this is the the porous materials in the left side in the zeolites, and right hand side is ones. So the inner surface area, for this case, is just in the zeolite in the basketball court, and the activated carbon is just the half size of field ball. But in the materials, almost same as larger than that. So can you imagine? You get 1 gram of these materials, you can get football court like that. Okay. So this is our materials. Yes. And then I moved to the university. And that time, the Professor Nakata, he said, so we are doing the copper 1 chemistry. So let's do this chemistry. So this laboratory is exact experimentalist. Okay, experimentalist. But I graduated the theoretical science. So I have to do experiments. Join this laboratory. Okay, and so we are focusing the copper 1. So what is the copper 1? Copper 1 of the copper and seemingly useless ion, because what we usually, you see the coin and something, and also the copper 2 and something like that. But what we really see is copper 1. So in Inorganic Chemistry Society, copper 1 is useless. So I was told by big professor, yes. However, MOF originated from the chemistry copper 1, because in the 1959, professor synthesized this kind of network structure using copper 1 and organic molecules. Okay, he determined the crystal structure, beautiful network structure. But 30 years later, Richard Rowe, he was also out the Nobel Prize together, and he synthesized diamond-like structure like that. And also he showed the synthesizing the network structure. Okay, he used copper 1. And the Omar Yagi, also the laureates in this field, he used copper 1. Most of the people use copper 1 because copper 1 easily give the networks. Okay, so and in the 1989, and I was interested in the structure using copper 1, but in the left hand side, you see metallic conductor. Okay, so I want to see metallic conductor. Metallic conductor means the electron pathway. There is an electron pathway. So that means we decide very densely packed structure. Okay, so today it's almost densely packed. Several parts is vacancies. It's not good. Fully packed structure is very good. So I was focused on that time. But soon after, and we determined the crystal structure. In that time in the Kinda University, we don't have a good facilities. So I went to university and to use the computer system. But that time I have time. And then we just analyze the intermediate structure and my student, there is a hole in the structure. I was so impressed because I very much interested in the highly densely, but he said, oh, this is good. I have a kind of the mindset, space. So I did not lose this chance. So that after that, I switch work from the dense structure to the porous structure. Okay. So in the case of the porous structure, but there are problems. Kappa 1 organic ligand binding strength is not. So this is the reason why we are easily get the network structure, but the big issue in this case of system. So our question, central question is synthesizing robust, strong porous structure. It's possible to get the picture. So there's almost similarly. I move on to the Tokyo Metropolitan University as a professor. Organized laboratory in this university. So it is robust, strong porous structure that time, and so evaluation of the Nobel committee of my achievement. That is the part 1. First, we demonstrated and also provide the porous structure, which show the reversibly adsorbed gas substances. Okay, so I did. In this university, I did. So this kind of structure, instead of the kappa 1, I use the cobalt 2 plus. Okay, and so I show this is the gas sorption experiment. We remove the gas molecule in the cavity. The structure is maintained, and then introduce gas substances. So we had the group seminar, laboratory seminar. So my student gave about this using this kind of the copies. So what is that time? One of my students kept seminar documents. So after Nobel, the prize announcement, he gave me this one. So that is 1995 October. So fantastic. That is also the raw data here. And in that time, still the people did not believe, okay, of the experimental error or something. But the Omayagi in the next year, he also stable porous structure. Then after that, the people believed so much interested in the synthesizing this kind of porous structure. So I call this stable structure is a second generation compound. One is just a network structure. Okay, just network structure. But the second, we can use this porous structure. So thanks to this property, there are many functions were discovered by many like this. So in the second, the evaluation report by the Nobel Committee. Second one is I discover and also they develop the soft, okay, flexible network structure. Okay, this is the second one. Just I said to you, and the dynamicity is very important. So all the people think about the robust, okay, left-hand side like this, very stable, never change. They are interested in this structure, but I am in the flexible structure depending on the guest molecules. So that is very important because we synthesize these materials from the organic molecules and the coordination bond. That is completely different from the rigid zeolites, inorganic materials. Okay. So, and I move on to we studied the dynamicity. So this is also my 50-year journey, okay, from the graduate students to today, okay. So my book, rigid framework to dynamic porous solids, okay. Yeah, this is the third generation compound I call here. So talking about this material, just I want to tell you our mindset and the dynamicity. So in particular the origins of these materials. Okay, part one is when I was a graduate student, I studied this kind of materials. Please look at the right-hand side structure. It's a histidine compound. This is very static. Nothing move, okay? Nothing change. But when we dissolve this crystal in the water, so depending on the pH, the bond change. Okay, bond form and the bond dissociation occurs like that. So that means this material is quite dynamic. The second one, the part at the Texas A&M University, I worked for Al Cotton. He was a great person in the compound. So I synthesized green materials, but just heat it into the brown materials. What's happening in this case? That molybdenum site rotate in this way. Yeah, very slow, but real reaction is very fast. But very fast. Green to brown, but very fast. So still you cannot imagine the flexible framework. So this is famous, the Hoverman toy. Here, this easily change the size, but the element does not change. So this kind of the motion happens in the crystal. So we predicted these properties, and then there are several types of the flexible system were found. First one in the this kind of the displacement is occurs. In the left-hand side is just a hinge type motion, and the bottom show expandable case or still interpenetrated case like that. Okay, so there are many this kind of flexible system were found. So one of them we synthesized is this one. You see, in the expandable case, and the movie, when we applied the gas substances, so apply to open, yes, and so the gate flows in this way. So this is very important discovery because so far the gas sorption is gradually solved. But in the left-hand side, you see this is a sigmoidal curve, S-shaped. So in the history of porous materials, this kind of sorption never found. Okay, so and thanks to these properties, so methane, O2, nitrogen, these are supercritical gas at room temperature, but distinguish these gas substances using the sorption profile. Now we are standing at this stage. We have the third generation compound. It's a very dynamic motion in that case. So this is the dynamic framework is more unique features. So let's move to part 3. Yeah, I want to show two flexibility is global dynamics. When the gas molecule are solved, they globally change. But the second one is the local motion in the crystal. So there are two types of the motion, global dynamics and local dynamics. So by using this, I will show the fantastic properties. In particular, in first one is the storage. Okay, here the acetylene. So acetylene is a very important gas substances, but very dangerous. When you apply at room temperature, abruptly explode. So, but we succeeded 20 years ago. We succeeded in the storing here. Okay, I published in Nature here. However, problem is to get the usable materials, we need to have some profile. Okay, this is the sorption, but the sorption is very important. In a certain pressure range, most of the gas substances can be here like this can coming out. In the case of acetylene, we have to control the pressure range is larger than 1 bar, smaller than 2 bar. Very narrow pressure range we need. It's kind of the properties. This is a question. Yeah. So this principle, but the mechanism. So we control this kind of deformation energy and the sorption energy. Okay. This is a competitive relationship. This is the chemistry. Yeah, I can skip this. Yeah. So this is the result. In the left-hand side, please look at the green. We can get this kind of sorption profile. Just changing the substitute molecules like that. So we are succeeded in getting this range and 1.5 bar. Very narrow range. We can the acetylene as very safe. And we store a lot of acetylene gas substances. Okay, this is the very successful story of the global motion. Okay, let's move on the second case. So this is important, even in this country too. And here, the total consumption for all companies, and just look at this, and the bigger company consumes 34%, almost 35%. The chemical company use mostly about 40%. So that means totally in Japan 12%, but in the Nature paper just introduced this kind of the version. This is 40%. Okay, and so fifth of the world's entire energy use. Okay, separation is very energy consumption process. In the chemistry world, we say just a recognition of the differences. So that's very important. We try to do the very important but difficult, challengeable separation. That is light water, the heavy water. Okay, so in the natural water, the content is only 0.00 something like that. Very minor content in the natural water. How we can get this kind of these? Okay, so the properties almost similar. Chemical properties almost similar. So this is 100 years puzzle. So people try to do this. Okay. Just as I said, the separation is very ending process. So please look at the bottom in middle. So this separation was done, and the upper side is just electrolysis. And even in the recent one, still the energy consuming big industries, big factories we need. So the size 1.05 or 1.02 or 1.2. That means if there is 1, we cannot separate. Only tiny amount difference they use. That's the reason why they use this. So it's very, very energy consuming. We need to have a new theory, new mechanism to do this. So this is very challenging. Okay, the new mechanism. Hi. Okay, so we think about the local motion. So next slide, you can see the local. Yeah, and in particular in the bottom, the movie. So in the channels, there is a local motion like that. Okay, this paddle moving. So we put this kind of motion in the side, in the upper side you see here, and so is this one here, and the wall very quickly diffuse, but in comparison with this wall, so that truly separate these two species. But inside, zeolite, activated carbons, other more materials, similar. So impossible. Only our case can do it. So this is the rotation. So we have addressed the challenging tasks using the global motion. Okay. So and because of the slow motion, this presentation time is almost out, but I want to show in the visited 1997 my work. Okay, this is very important in the just the beginning of this chemistry. So there is the mystery because this materials is smaller than the gas molecules. Cavity size than the gas molecule. How gas molecule is coming in? This is big. So we did this one again. Almost 27, 3 years ago. Okay, we did this chemistry, but that time we had not such enough and instruments. So now we have a lot. So we carried out. So this showed very smooth way. Why so? This is here. The narrow gauge is constructed from the bipyridine in the right. You see? So this is just like a open gate, moving gate. So in the channels, the local motion occurs. So this is because first morph materials we did 1997. Okay, 1997. That was so we have already found third generation material. So that means in 1997 materials contains everything. Third generation properties. So that is my case. I was very impressed. Okay, in the Nobel week, I attended the Nobel week in last December. So the day is just a Nobel museum, and they all know it together. And also we donate the important materials, memorable things. So we synthesize this kind of memorable materials, and also we made the handkerchief, very important, just like this. Okay. So I was very interested in this 1997. So I like this, and I made the tie. Okay, this is a network. In the Kyoto is very famous. The factory produce this kind of things, and also the right hand side is I was given by Kyoto Prefecture, like that. So today is very important, the costume. So I have no way to show my tie. Just look at the slides. I want to wear a tie on this side, but this is not good. Okay. Okay. But anyway, hi. Oh. This is just the museum, and right on side, upper side is just a signature. And this is the Nobel lecture in that case. And so next one is, yeah, this is ceremony. And to that time I was so busy, I had thinking about this kind of award. But in this ceremony, myself, oh, this field is widely recognized. Ceremony, yeah, I thought. And the Nobel banquet, next one. So huge city for the many people they attended in here. So I was so honored. I escorted the crown princess sat next to myself, and I really enjoyed 4 hours dinner. 4 hours dinner, only 3 dishes. Soup, main, dessert. I went out to go the toilet 4 hours. Yeah, very honored, very honored. Okay. So yeah, very slow. Oh, okay. I hope you understand my history like this. When I was a graduate student, I had 3 notions. So I realized in universities. So that is a kind of story of my realize my dream. So in the last part, but the time is up. So I quickly, my wish, I want to quickly change, but okay. So all over the world, there are many startups about MOF materials. In the 55, and I could not count China. If I the startups in China is over 100, maybe, I think. And of course, in here the Atomis University, the Atomis is created. The Atomis, right now already the commercialized this material and coating materials and and also the separation of the fluorocarbons, and also this country also of the fuel gas substances. Maybe this movie does not move. So what is interesting is also the another startups. This is the Northwestern University in the MOF technologies, Numat. They show this kind of a mask, okay, for like that. And what is important is Atomis also already you are familiar with this cubitum. So lastly, I want to tell you about this. And this is a concentration of the CO2 content. And you see, in the biogas contain 50% CO2, but the flue gas is 50% CO2, and natural gas 5% CO2, and air contain 400 ppm. Okay, very dilute CO2 concentration. So that means very energy process we need currently doing this process. So we need to have the new materials, okay, low energy cost system. So, and this is a big, and for the next 10 years. So of course, in Japan, I have a collaboration companies to separate the CO2 fuel gas and the product, the petroleum company. So this is the separation system in Canada, in the George Shimizu. He produced very interesting materials. This material is applied for the separation from the cement company in Canada. So this is right now the stage of the storage, also the membrane, and so on and so forth. Anyhow, my message to particularly young people, we are now standing at the gas age. So the just gold, black gold is petroleum and coal, but we are air gold, in air gold. So this is my final. Just a moment, just sit, waiting. Oh, okay. So, right bottom, okay. I told you Chansu, 2,400 years ago, Chansu said, of the useless. Another chapter, he said, okay, just do not eat grains, but the absorb wind. There are no concept about air, only wind they feel. Okay, breathe wind and drink dew. 24 years ago. So that means live by use of mist. Mist contains the air and the water. So 2,000 years already predicted. So now we think, okay, direction. We use air, okay, in another sense, mist. We live with mist. This is our next 10 years, 20 years, our vision, okay. Everywhere people use air. Okay. So to do this, in particular, the young scientists just create new science and develop technology. Okay. That is my last messages. So thank you very much, and funding agencies and the all people, my friends, my families, myself. So thank you very much for your kind attention.
Thank you very much. Thank you very much, Sensei, for such very wonderful and inspiring presentation. It's very amazing and very masterclass. Ladies and gentlemen, we have time for a brief question and answer sessions. If you have a question, please please standing mic. And we need to divide into two sessions. For the first session, I'd like to our VVIP guests to give a question, if any. Yeah, please. Can have the mic. You can use this one.
Thank you, Professor, for the very impressive. Professor, in our discussions before your lecture, that excessive populations concentrations in a few megacities like Jakarta, especially in the face of disaster. This year, we continue to face a long-standing challenge. Populations concentrated in a few cities, while vast regions remain under-inhabited and, more importantly, under-imagined. Historically, transmigration has been treated as a policy of necessity. My question is, how can transmigrations or any large-scale human movement be imagined not as an obligation, but as an act of curiosity and aspirations? What makes people want to move? Not because they must believe there is a future worth building. Thank you.
Yeah, but I think this is one of the sheet suggestion my case, and right now our culture is just everything centralized. People centralized in the one city, and also the industries, and also fuels and the petroleum are centralized, and this and separate, and then deliver to the local city. This system is very bad for the future. I think mostly the small, each individually developed the fuel and food and everything. So locality is a good the point, I think. So to do this, we have to develop the new science, in particular in the air located everywhere. We don't need to transport this material or the district. So focus on air. That's air also gas substance. So this is the last material the human did not study, in particular in the established the industries and also our daily culture. Okay. Gas substance is very important for the future.
Thank you very much, Sensei. Is there any other question, audience? Professor Jiman?
Thank you, Kitagawa Sensei. We are very inspired by the 50 years of nanospace. So, and then in Indonesia at the moment, we are putting and also investment for our young talents. So we would like our young talents to build yourself. Do you have any key secrets or key motivations that keep becoming someone that, as you earlier showed us, that the pinnacle of world's development? What are the key secrets that you could probably share? Thank you.
It's very important question.
Yeah, very important, I think. But my case is a very special case. It's difficult to say my career. But one thing, the young people, the contact, the wide world, the various type of the culture is very important. So imagination, if you focus on, for instance, in this area, they grew up to the end. So only one culture. So if you go out, abroad, and different area and something like that, that's very important. So please, this kind of experience. That's the point, prepare the mind. To brush up, prepare the mind. That's the point. So you cannot go abroad, go other places, because you can read the book, different books. Tell us the different life, different culture. So you have to read the just various books. So internet okay, is very important, is very good, but very quickly give us just, but only the fraction of knowledge. But books, in that case, you read from the beginning to the end. It's kind of or logic. That's very important, I think. There are two things. Yeah, I understand.
So do you think some people, if it will be Nobel Prize winner like you, do you think? So I'd like to invite for the next round for young scientists from the universities. We have identified from the committee the question rise from audience. For the first question, I'd like to invite Dr. Osi. Is you here? Yeah, please.
Good afternoon. My name is Yarutanti from the Center for BRIN. Thank you very much for your inspiring lecture, especially for me. I'm wondering about when the first time you introduced about the porous material and mold. Did you expect or anticipate that material would evolve the multidisciplinary platform for chemistry, physics, engineering, and thank you.
Now the stage of chemistry is just discovery and application. But if we foresee our society, materials is very important. I don't insist on just porous materials. Porous materials are very important. Okay. And so separation, storage, and the conversion catalyst, sensing. Sensing is also very important because the materials is the tailor-made for porous structure. We can capture the very specific molecules. For instance, our body produces some of the gas substances, but we don't know yet. So if we have detect this kind of the gas substances, very special diagnosis, disease or something, or monitor our health, or in particular the airport and just a contact detection. But our materials are also very gas substances, non-contact stage. So that's very important. Yeah, there are so many applications, of course.
Thank you very much.
For the next question, I'd like to invite Professor Rino Mukti from Bandung Institute of Technology.
Thank you. Sensei, Tagoa Sensei, welcome to Indonesia. Thank you for visiting us and inspiring lectures. So I'm Rino Mukti from Bandung Institute of Technology, and I would like to introduce also my from Catalyst Group from TTB. Thank you, Sensei. Professor. So I'm a former member also from Okubo Sensei. So my question is, you already explained to us that the application of the MOF now into commercial business separations about the air goal. Do you think any opportunity to get really other applications such as catalysis, maybe sensing or use? Maybe what is your comment? Thank you.
Okay, so which is important in the next 5 years, something like that. Okay, maybe the next thing, and the separation, you just follow this storage. And after separate special gas substances, what we should do? That's very important. So catalyst is the next step. This is something, for instance, the usually gas reaction, gas using gas material reaction, because in the low concentration, but in the porous material can concentrate this gas substance more. So we have a chance. This, okay. And the sensing in the other the electronic mix material is also important, of course, but the scale up high quality materials can use in the high scale. That's very important. For instance, if you think about in a small pan, you cook very delicious one, but be sure to get very huge vessel or not cooking your food. It's the same taste. It's a big issue. So scale up and also low cost production. If we clear this one, so that we can apply more and more sensing and electronic devices, I think.
Thank you. We still have time. Since for the next question, I would like to invite Dr. Ahmad Afandi from Research Material for Energy BRIN, please.
Good morning. My name is Ahmad Afandi. Good morning. My name is Ahmad Afandi. Actually, I'm alumni from Kyoto University. Obtained my PhD in 2020 faculty. So I remember every early of October, media waiting for information regarding the Nobel announcement. But during my study, it was not my opportunity to witness one of the professor to win the Nobel Prize. But now I'm so that you finally winning the Nobel Prize. So I have a question regarding the metal organic framework, emphasizing the flexibility and dynamic structure. So what is important for the future application, whether it is a framework adapt or structural rigidity? As you mentioned in the last presentation about air-cooled, what will be the most aspect? Thank you. Thank you.
Yeah, the substitution compound. Yes, hold on. For instance, please think about your hand. If your hand does not move, so the emission of the molecule, there is quite limited. But this can move. Any molecules, species, you can detect it. So it's an issue of recognition. Flexible system is a very superb function. So that means in the separation, okay, very applicable in that case. And also the storage, just show the acetic storage, very sharp sorption, okay, sharp region is required for the sorption. But usual material, impossible to apply this kind of storage. Okay, storage, separation, even in the other sensing system, just change like that. So the soft materials is very, very promising. So MOF is one of the farm. That is my vision.
Thank you. Now I'd like to invite one more question from Dr. Witt from 11 November University. 11 Maret begitu. 10 November.
Thank you. Yes. My name is Witri Lestari. I am from university. It's called UNS. Yeah. It's located in Solo, Central Java. It is a pleasure to come with you, Professor Kitakloa. I am one of the scientists that have an idol in MOF chemistry because I studied this field since my master in Germany. And also my doctoral degree also in the chiral MOF and coordination polymers, profession of Professor Hawking. And as this Nobel Prize was announced, Professor Serra in Paris with the SSHM program. That's why I'm very happy of chemistry or MOF chemistry. My question here is, how can MOF chemistry meaningfully to global sustainability challenges such as carbon neutrality and as you know, here in Indonesia we have several sustainability challenges as energy, and how with this MOF chemistry we can contribute. The big issue is about upscaling. Because itself for synthesize is not easy in my opinion, and the cost is very high. You have suggestion about that, or we can like combine with natural porous material like zeolite from the volcano, for example, or how this. Thank you. This is
Yeah. So I thought in my lecture. So the gas substance is very important in big air society. The air control is very important. Right now, we use this. So that means from underground to the CO2 into the atmosphere. It's a one way. Okay, we have to cycle kind of the materials which okay transformation like that. So the porous materials are very important. So MOF is a brother, elder brother. COF is a younger, and the other is a baby like that. So all just follow this MOF because MOF exactly determine the crystal structure. The design this framework. Okay, COF is no metal materials, just organic molecule based material. So if it appear, nothing happens in the next one because the crystal structure. So more study, okay, and the people believe, oh, molecule, even molecule can give this kind of very definitive structure. And then organic based material coming down, but difficult to determine they can predict or expect like that. So my opinion is porous materials are very good. Many porous materials, of course, zeolites, activated carbons. Okay, so we have to develop new chemistry and technology using the porous materials. The next feature. Five is gas substance.
Thank you very much, Professor. Wonderful and very inspiring talk, and please pause for Professor Susumu Kitagawa. Thank you very much. I trust Masa.
Once again, thank you very much for Professor Tagawa for the extraordinary lecture, and also Professor Agus Haryono for guiding the session. Ladies and gentlemen, please give round of applause for Professor Kitagawa. Ladies and gentlemen, next is souvenir presentation, and we would like to invite Honorable Professor Arif Satria. Now, ladies, as is press conference that will be held at the press room, and for that we would like to invite Professor Sawa, Professor Arif Satria, Mr. Miyochin Mitsuru, and Professor Ratno Nuria come to the press room once again, ladies and gentlemen. Next is press conference, and for that we would like to Professor Suzumu Kitagawa, Professor Arif Satria, Mr. Miyochin Mitsuru, and Professor Ratno Nuryadi come to the press room. Ladies and gentlemen, this is our Nobel lecture session, and we are going to have a lunch break, and we are going to event at 2 p.m. Thank you very much for your attention, and Assalamualaikum warahmatullahi wabarakatuh. Ladies and gentlemen, let me inform you that the auditorium is used for MOF ASO session later, and then the young scientist meeting will be held at room 001 at first floor. And the lunch for the VVIP is at the first floor in front of the registration desk at the classroom, and the lunch VIP guest is at room 1002 first floor, and other participant may take your lunch at the first floor. Kami informasikan kepada seluruh hadirin bahwa makan siang dapat diambil di lantai 1 di tengah. Sekali lagi, kami informasikan kepada seluruh hadirin yang hadir yang dapat diambil di lantai 1 di area tengah. Terima kasih.
Tadi pagi makanya tadi udah itu internetnya absennya absen pas enggak lama nanti saya ya tapi benar saya dan grup karena sudah Nobel bilang begitu kita pasti Gimana? Ayo.
Sekali lagi kami infokan kepada Bapak Ibu untuk bisa mengambil makan siang di lantai 1 di area tengah. Sekali lagi kami persilakan kepada Bapak Ibu untuk bisa mengambil makan siang di lantai tengah. Terima kasih.
Kotak hijau.
Tasnya ada.
Bahwa ya nggak apa-apa.
Kita sama-sama duduk di
Ya, asli.